When we think of the greenhouse effect, we often think of the influence of the increased CO2 in our atmosphere. But how often do we think about other greenhouse gases? Scientists have observed that other gases that absorbed long-wave radiation have shown significant changes in recent decades. Join us as we look at some of these and their effect on our climate. One of these other gases is water vapor. Yes, water vapor, the gas form of water, or H2O. This is the most predominant greenhouse gas. Like CO2, it absorbs and re-emits infrared radiation. It accounts for about 2/3 of greenhouse warming, while CO2 only accounts for about 1/4. But water vapor differs from CO2 in a very important way. Its concentration in the atmosphere is not controlled by human activity. Instead, air temperature exerts the primary control. Warm air holds more vapor than cold air. Cooling causes condensation and the loss of water vapor as rain or snow. Water vapor is best viewed as a greenhouse effect amplifier. When we add CO2 to the atmosphere, we absorb more outgoing infrared radiation, which retains more heat. That additional warmth in turn allows the air to contain more water vapor. That additional water vapor then absorbs more infrared radiation, which adds even more warmth, and so on in a self-reinforcing cycle. This reinforcement more than doubles the warming potential of CO2 on its own, an effect that we call a positive feedback. So even though water vapor is not supplied to the atmosphere by human activity, it is an important and amplifying greenhouse gas. Because the Earth has warmed over the last several decades, direct measurements show that there is now about 4% more water vapor in the atmosphere than there was in 1970, an increase that continues to strengthen planetary warming. Let's leave water vapor and CO2 and look at some other important greenhouse gases. Scientists have observed that other greenhouse gases have shown significant changes in recent decades. 3 warrant particular attention. They are methane, chlorofluorocarbons, or CFCs, and nitrous oxide. Methane is a greenhouse gas produced by decomposition of organic matter in the absence of oxygen, as happens, for example, in mud in rice paddies, and in the guts of ruminant animals like cows and sheep. As populations have grown and diets changed, more and more land has been converted to raising livestock and growing rice, and more methane has been released into the atmosphere. Chlorofluorocarbons are gases manufactured by humans that have been used as coolants in refrigerators and air conditioning, and also as propellants in aerosol cans. Their use has produced unintended consequences. Although only present in trace concentrations in the atmosphere, they are powerful greenhouse gases. Moreover, they have another impact. They react chemically with ozone high in the Earth's atmosphere. Ozone is a chemical compound made of oxygen atoms that absorbs ultraviolet radiation, protecting us from sunburn and skin cancer. It was discovered in the 1980s that specific CFC compounds were depleting ozone in the upper atmosphere, and as a result, their use was banned by international agreement. The ozone content in the upper atmosphere is projected to recover over coming decades from this serious global-scale impact, and made us think carefully about our lifestyle and development choices. The concentration of nitrous oxide in the atmosphere has also been steadily rising in recent decades. It is produced by bacterial activity in soils, particularly in farming, where significant quantities of nitrogen fertilizer have been added to farmland. This chart shows the relative effects on warming made by the well-mixed greenhouse gases in the atmosphere. Carbon dioxide accounts for more than half of the total contribution, methane almost 20%. Synthetic gases including chlorofluorocarbons or CFCs, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride nearly 15%, and nitrous oxide about 6%. Human activities have increased the concentration of all these gases in the atmosphere in recent centuries or decades. In summary, even though CO2 is a major contributor to global warming, water vapor also plays an important role because, like CO2, it absorbs and re-emits infrared radiation. We also must not ignore other gases such as methane, synthetic gases, and nitrous oxide, because we now understand their relative effects on warming.